Okay, so today we're going to talk a little bit about, what digital twins actually mean in the industrial space and how we can leverage them. Um, I get this question quite a lot, actually. I mean, lots of people are confused what digital twins actually mean. There's different technologies, different groups claim that they own or define what digital twin is, and it's not that simple, right? I mean, fundamentally, there's plenty of different digital twins out there, and they all have a reason to be, right? So let me give you my definition. So in general, really the big new innovation in Industry 4.0 was the digital twin. A lot of the technology that we're using today in Industry 4.0 applications existed before. And what's really new is this concept of digital twin, but it doesn't mean that you need to, throw everything away that you have already. But, really it's a new word for something that you've probably been using all along. So in general, a digital twin is a representation of a physical asset in the digital world, right? So those physical assets could be machines or systems, databases, whatever, right? And digital twins have many different shapes and forms and sizes. I mean, for example, lots of people think of a digital twin as a wireframe model, right? So a lot of the digital twin discussions within Digital Twin Consortium that I'm on the board of the Digital Twin Consortium, and a lot of the discussions are actually around 3D wireframe models and how to display them using something like the Unreal Engine and stuff like that, right? So obviously, we also have companies in the manufacturing space that have made substantial use of these 3D wireframe models or even shaded models for really creating this 3D environment of their factory or their oil rig, whatever it may be, and you can fly through the factory using a rendering engine just as if you were physically there, right? So that certainly has its value and its merit, and you can click on things and get telemetry data from digital twins directly in that 3D environment. Another important definition of a digital twin is actually the automation ML language, and creating an automation ML representation for your engineering systems, right? And we talk a lot about making that simpler and automatically converting from automation ML to OPC UA, during deployment, and that's actually something that's covered through a companion specification, right? And then of course there's the OPC UA information model, which is kind of the operational digital twin, if you like, right? So basically when the machine is humming, data comes from it, you can interact with the machine. The interaction interface is OPC UA, and you could argue that then the OPC UA information model is the digital twin of that machine. Other folks think of a digital twin more as metadata that you can't really interact with, like static data that comes with the machine, like the nameplate or calibration data, or even the manual, the user manual, right? And yet other companies focus on creating digital twins for simulation, right? So basically, simulating the device, maybe it's an expensive piece of kit and you want to see how it reacts in certain environments. So you might want a simulation to basically test out that particular system. And then at the most basic level, if you think about it, your function blocks that you've been using all along, right, in your machine could also form part of a digital twin. So it doesn't really matter what a digital twin means for you in terms of what data is contained in it, but fundamentally creating like a collection of digital twins and putting them in one place and being able to, create that digital twin with a single data model is very important for some of these Industry 4.0 applications to do analytics, to do deep insights, machine learning, and so on. So really, the digital twin gives the data that you're going to be reading from the asset meaning, right? So that's fundamentally what it's all about. So moving on, the main part of the industrial digital twin is that it has many names, right? So, the platform Industry 4.0 calls it cyber physical system. Our friends in the US call it smart manufacturing profile. Already mentioned, a few others like Digital Twin Consortium, which just calls it digital twin. The Industrial Digital Twin Association, which is relatively new, calls it, the asset admin shell. And of course, the OPC Foundation calls it information model, right? So it has many names, but effectively what they're describing is the metadata describing the data for the physical asset. So now that we kind of know what a digital twin is, are there any standards out there where you can really think of, standardized digital twins that always look the same? And before you even connect to the interface that the asset provides, you already know what the metadata looks like. Wouldn't that be great? Well, it turns out OPC UA so far is the only technology in the industrial space that makes this available at scale. So, and that work is being done by the VDMA. I mean, they have over 450 companies involved working on these standardized industrial digital twins leveraging OPC UA. They have over 35 working groups. It's probably even below that number. They probably have more. And these standardized data models, information models, digital twins, whatever you want to call them, are then published to the OPC Foundation, and they're part of the OPC Foundation spec. So they're part of the standard. And the OPC Foundation actually maintains a GitHub site where you can download the resulting node sets. So you can include those node sets directly into your OPC UA server and leverage them. Some of the industrial connectivity companies also allow you to map any machine to these standardized information models. So you basically, like softing data feed or PDC Kepware, you load in that standardized data model and then map your, proprietary machine asset to that standardized data model. And you've basically just standardized your machine interface. So then, we had all these information models available. And somebody said, well, wouldn't it be great if we had like, a global repo where you could actually search for these and download them and, query what's in them? So more than what GitHub allows you to do. So then we created the UA Cloud Library working group within the OPC Foundation. And next week at SPS 2021, we're going to release the Cloud Library. We've been working hard on the specification. We've been working hard on a reference implementation on GitHub. And the OPC Foundation is also going to host a global instance. And again, you can search for standardized information models. You can search within them. So if you're looking for like a motor, right, you can find all information models that have a motor definition in them. And allows you the automatic integration of those information models into analytics software. So the idea is that you query that global instance, or you can set up your own instance. So if you have a bunch of information models that you don't want to share with the world, that's fine too. Just create your own instance of the Cloud Library in your cloud or on-prem and host your information models there. And you can query them and integrate them into your time series query. So if you want to know what a time series, where that time series belongs to, if you have OPC UA pops up, you get your node IDs in there, so you can look up your node ID and your application URI in the cloud library, right, for that particular information model. So we're really happy that we finally got this released. It's an important step. So again, I mentioned automation ML, I mentioned OPC UA information models. What people forget is that these two technologies are set in the reference architecture for the Industry 4.0, for the platform Industry 4.0. So, all these people that talk about Industry 4.0 applications, if they don't use automation ML or OPC UA, they're not compliant. End of story. Right? So you got to use automation ML and you got to use OPC UA. Now, of course, there's this concept of the asset admin shell. So how does that fit in? Well, the asset admin shell is the shell around these information models. So it's like a container. That's what you can really think of it as a container. So in general, the asset admin shell was designed to be a shell, a container for administering an asset, for managing an asset, and it could include anything, right? It could include an OPC UA information model, like a node-set file. I have some open source software on my GitHub account to show how to do that, right? Or it could be an automation ML model, or it could be a PDF with calibration data, or a 3D model for the Unreal Engine, whatever it may be. Excuse me. You can put anything you want in there. At the end of the day, the file format of the asset admin shell is Open Office XML, right? So it's basically just a zip with an XML file in there, basically describing the content. Yes, you can also model data inside the asset admin shell, but it was always meant to be a container of existing data that belongs to the asset. So don't start remodeling your assets if you already have a model. Instead, take the model the way it is, stick it into the asset admin shell, and distribute it that way. So of course, Microsoft, in case you didn't know, I do work for Microsoft. So Microsoft also has a service called Digital Twin Service. And it's a proprietary service, but it's built around the concept of the digital twin definition language. It's a JSON-based language, and it allows you to create digital twins, define properties for them, and then integrate that digital twin service into your analytics pipeline to get analytics insights from your assets as the telemetry of that asset flows to the cloud. So it's kind of an analytics. It's like an analytics software that leverages telemetry data flowing to the cloud. And of course, you could go and basically model your digital twin definition language representation of your asset from scratch, or if you have an OPC UA information model already, you can create, use a tool and I've actually built a tool that allows you to extract the pieces from OPC UA that DTDL can leverage. And there's no comparison between DTDL and OPC UA. OPC UA is much more powerful, but instead of modeling everything from scratch, you can just import the pieces from OPC UA that the Azure Digital Twin Service leverages using DTDL, and you save a bit of time. So is there a tool available? Yes, there is. It's called UA Node-set Web Viewer. It's in my GitHub account, and you can use it today to basically do exactly that. So it generates, or it can read an OPC UA, it can read an OPC UA model It imports from the OPC UA model selectively some data, turns it into a DTDL model, and then stores that model in the Azure Digital Twin service. It can also actually generate an asset admin shell, a shell around either the OPC UA information model or a shell around the DTDL model. Is really up to you. But if you want to make those asset admin shells available to your supply chain, because fundamentally the asset admin shell was built and designed for communicating data from one database in one cloud to another database that is most likely in another cloud platform independently. So you can use the asset admin shell as a container format and distribution mechanism for metadata that is contained within it. And you can also stick it into a web server, make it available for download for your customers. So a concrete example of all of that is what we're going to show next week at the SPS show. So the Platform Industry 4.0 and the Clean Energy and Smart Manufacturing Innovation Institute in the US have worked together. We created a position paper on sustainable manufacturing at HMI this year, and this demonstrator is kind of a direct result of that collaboration and builds upon the position paper and how to do carbon reporting. So in general, if you're not familiar with how this works, there's three types of emissions that you can have in a manufacturing facility. There's the direct emissions, which are scope 1 and 2, basically your burning of fossil fuels and your electricity bill. And then there's the so-called scope 3 emissions or indirect emissions that come from your supply chain and are then also passed to your customers, to your distribution channel. And those emissions are actually 80% of your total emissions when you're producing something. So it's super important that we start tracking those emissions too. Everything else is what Greta would call greenwashing, right? So we would have to create a mechanism where we can extract from the OPC UA server the power consumption, calculate from that the CO2 footprint based on the energy provider and what kind of power plants that particular energy provider that you're leveraging in your production facility runs, right? If it's mainly renewable, that CO2 emissions or those CO2 emissions are going to be low. If it's mainly coal, it's going to be high. But you need to multiply then your energy consumption by that multiplication factor that you will get from your energy supplier to calculate your scope 1 and 2 emissions. I mean, most machines don't burn fossil fuels, so it's mainly electrical energy that you need to monitor. OPC UA obviously allows you to do that. So we created a little telemetry pipeline where we're sending that energy consumption to a time series database. We have a dashboard that shows the data that we send to the cloud. We're looking up the OPC UA information model in the UA Cloud Library. So we can associate the time series data with the OPC UA information model. And then we have an asset admin shell server that queries both databases, the UA Cloud Library and the time series database, and generates a carbon footprint report on a per produced component basis. So this particular machine is a festo-didactic learning tool, and I think it just moves things from left to right and right to left, and so it's kind of a theoretical number that comes out of it, but we're basically just trying to show how the whole technology works together. And so you end up getting an asset admin shell that you can download through the asset admin shell viewer that the Platform Industry 4.0 has, and look at the carbon footprint on a per asset basis. So I think every minute it moves this piece of plastic from left to right, and that's basically the production step. And then it calculates how much CO2 was produced by moving this piece of plastic from left to right. And if that piece of plastic eventually makes it into a product, and that product should be attached with a carbon footprint sticker, then those CO2 emissions can be added up and put onto the sticker. So that's a concrete example how the whole digital twin technology works, and creates a real use case and creates real results. So thank you for your time. I hope it was informative.